Welcome to The Defiant. I'm your host, Tegan Klein. Today, we are joined by the dynamic Ethereum KZG Ceremony Duo, Carl and Trent of the Ethereum Foundation, the nonprofit organization dedicated to supporting Ethereum and related technologies. With Carl and Trent, we dive into the KZG ceremony, why it's important for scaling Ethereum. We dive into the ETH roadmap, demystify jargon like Dank Sharding, EIP 4844, and we talk about the culture of the Ethereum Foundation, why Ethereum has become a bit more adversarial with time, and how they plan to continue scaling without sacrificing decentralization or censorship resistance, and so much more. But first, they tell us their origin stories about entering crypto, why they joined Ethereum, and what they're focused on today.
My background is in architecture and design, so completely different from, typical developer path or really anything in crypto. I guess there's not really an undergraduate path into crypto yet, maybe in a couple of years. But yeah, so originally my background is in that space. And I did that for a few years after graduating. But found, the profession is very, very slow moving. It's more conservative. You're dealing with a lot of code reviews and getting permits, things like this. It's very different from the way you're taught it in school. So I got a little disillusioned with the profession. And then around that time, I also found crypto, Ethereum specifically on Reddit, and just got really, really deep into the community. This is about 2016. And just ended up getting deeper and deeper, decided to leave architecture and worked for a couple of different companies, Whiteblock, ETH Global, and now I'm at the Ethereum Foundation, I think 2 years this month. And I do things like helping the community engage with network upgrades, engaging them with the different ways the protocol is changing, making sure that they're aware of different developments that are on the horizon, things like that. So it's a lot of back and forth, talking with people, connecting people to someone who's looking for a specific person. And then, two of the big projects over the last year have been the KZG Ceremony, which we'll get into, but also Protocol Guild, which is this collective of core contributors, 130 core contributors that are working to enable distributed funding of the core protocol. So maybe that's a topic for another discussion, but yes, that's a little bit about me.
Yeah, my path, I got into the space when a friend of mine basically started making a lot of money out of this whole crypto thing, which I hadn't really heard about. I knew it existed, but hadn't really dug into, and I was like, hey, that sounds like a thing I would like. Anyway, so at the time, I was very into the machine learning and AI space. So I started building some trading bots, which was a fun intro, but that grew old very quickly. So I started in my free time, just digging a little bit more, seeing what this is all about. And it really hooked me. There's just so many interesting problems to solve, but I was like, hey, this is actually really cool. At the time, there was a proposal to switch over to proof of stake. This was back in 2016, 2017. Called the EIP 1011. And that was to stake there, you would need 1,500 ETH, which I did not have and still do not have to be able to stake. So I was like, hey, that really sucks. So I came up basically with what we'd call distributed validator technology, DVT, today, but I came up with a similar idea to basically just split up this 1,500 ETH between myself and a few other friends interested in the space. And then I was working on networking problems and consensus problems and cryptography, and slowly just sunk my teeth more and more into the protocol. And then eventually when I realized that EIP 1011 wasn't going to happen, I made the switch to just working on the core protocol and essentially doing very similar things that I was with this whole splitting up stake idea, just at a different level of the stack.
Amazing. Yeah, Trent, I love how you kind of have that unconventional background, because a lot of people can get involved in this space. And Carl, I love that you came in kind of from the trading side, as many people do, but then you kind of went down the rabbit hole and got deep into it. I know we're eager to talk about the KZG ceremony, and we'll get to that in one moment. But before we dive in, I want to ask a little bit about the current culture around the Ethereum Foundation, because Laura Shin, as I'm sure you both know, wrote a book on cryptopians around the early scenes, and there was a ton of drama. So what is it like working at the Ethereum Foundation these days?
So I actually haven't read the book, but I believe it's around the very early days. And as people can probably understand, things change over the years. So it's a very different organization. It's probably much bigger now. But the culture is great. It's honestly the best place I've ever worked. I feel really privileged to be able to work with the people that I work with and do the specific work that I'm doing. I couldn't ask for a better organization. I'm very happy. But in terms of culture, I guess not to lean too heavy into crypto terms, but permissionlessness is the default, or autonomy is the default. Very, very much so, in that people are really encouraged to explore what they think is interesting. Obviously within the bounds of kind of the work that they're expected to do, but there's a lot of freedom. I wouldn't say it's like tenure for an academic, but you can explore something that you find meaningful, as long as you're working on it. But yeah, the flip side of that is you really have to be a, I guess, self-starter or intrinsically motivated to do this work, because nobody's going to be, it's not like a Web 2 job or traditional employer where somebody's going to be looking over your shoulder, checking in on your work. You really have to be motivated to do this stuff on your own. But that's the great part of it. If that fits with how you work, you can do some awesome things. And I've really enjoyed my 2 years here so far.
Amazing. Carl, anything you would add?
I mean, yeah, I think there's a culture of sort of, we break ourselves up into teams. And these teams are very different. Like each of these teams should have different focuses, but they're their own internal culture and their views on what should happen with Ethereum. So like as a technology and as a space and like what the role of the EF should be are all very different. And so, I mean, we share all the same high level goals, but like how we get there and like what this ultimate vision of this technology is very different for everyone. And so that makes for some fun discussions with everyone. But like, I think it's just like, everyone very passionately believing that there are like many different and interesting ways of getting to the same goal. And so I think like depending on who you speak to and what aspect of the protocol they're working with and which team they're a part of, you're going to get very different answers for like how they go about things and what their views are for what the EF should be doing and how we reach this final like goal of whatever you would define that to be in the EF.
Amazing. Yeah, I want to get into some of the efficiency questions on that in a bit, but let's dive into the ceremony. So before we do, DMars300 of Twitter asks, how would you explain the ceremony to a 5-year-old? And maybe let's use like Legos or blocks so that we can kind of keep it in 5-year-old terms.
Well, Carl, we're going to do this together. So the KZG ceremony, I'll go first and then you can tweak it. Is you're building a Lego set and you, each person, so everyone in your family is contributing one piece, and they don't actually know which piece they're contributing. And someone assembles it for you. So you're each contributing one piece, a small little Lego piece, and you're building this house. And the house is going to be, used at the end of the construction phase. What am I missing, Carl?
I mean, yeah, I think it's a good analogy. Like if we were to imagine a dark room and everyone gets a little like piece of Lego that they're going to go add to this construction.
There we go.
And you can't, like when you're in this room, you can't see what this construction is. You just get your piece, you add it in, and all you can know is that you added in your piece correctly, or like you added it to the structure. So you helped build something, but you have no idea what was actually built. And like, because everyone has like done this independently, that we know that there is some structure that was built. And as long as everyone like responsibly built their little part, then together we have like an overall like construction that we don't even know what it looks like. Like under the hood, we can't peer into it, and we use fancy cryptography to hide this. But yeah, in essence, there's just this like dark room where we can't view into it. There's like really cool structure that we're building that we have no idea what it looks like.
Yeah, and there's no instruction set for how to put it together or take it apart.
What are you trusting in this example or within the ceremony? What do you have to trust, if anything?
We have this role called the sequencer, which is basically the bouncer outside the stock room, and they get to decide whose turn it is to go next. So their role is to make sure that like the same person doesn't just like keep coming back. So we need to like check that everyone like fairly has a turn, and that you don't spend too long in the room. That like you do your job and you get out of there. Just because we need everyone to have a fair turn again. So the sequencer's role is, as the name implies, just a sequence. They choose who goes next, and when like that you honestly get a turn, and that they let you do your role. So the trust assumptions here are basically that the sequencer gives everyone a fair shot at being included.
But yeah, the sequencer can't corrupt the final output. All it can do is it could censor someone from participating, but it would be pretty easy to tell if you were being censored in that. If you submitted a valid contribution, or if we're sticking with Legos, if you added your Lego piece properly, and the sequencer couldn't change that output or like the final construction of this Lego house.
Got it. Okay. Thank you. That's very helpful. And then I want to get into the roadmap a little bit. So you just coordinated the KZG ceremony, which I believe enables polynomial commitments, Dank Sharding. Let me know if that's correct. And then can you guys give a view on the near and long-term roadmap?
Sure. So actually, it's not actually complete. We're in a bit of a lull right now. So there were three, I guess I'll just give like an overview of the project. So we actually started this, I think, around last May of last year, and have been working on it since then. The first few, I say 6 months, we're developing the cryptography components and getting the first audit. And then we actually did a demo on stage at DevCon. We had hoped to kick it off then, but the Wi-Fi gods conspired against us. And then we did some refinements, had another audit, and then actually kicked off the ceremony itself in January. And we kicked it off on Friday the 13th in January, and it ran for 2 months. And this was an open contribution period where anybody could show up to the hosted interface, which was at ceremony.ethereum.org, contribute some entropy, go through the hosted interface, and then their contribution, their randomness would be included in the ceremony. They could also do it through a CLI, so like code that you're running locally on your own computer that would send your entropy to the sequencer. So there were a couple different options, a number of different implementations. So similar to how Ethereum has 10 different clients that operate at different levels of the stack and do different things. The ceremony had different clients, and this is really important for decentralization, but also reducing the possibility of there being a bug in one of them. And if we used only one implementation, this bug would be pretty bad. So we had multiple clients, and anybody could contribute during this open contribution period through those clients or the hosted interface. So that just finished a couple weeks ago, this first open contribution period. And now we are just about to start the grants period, or the special contribution period, which was funded by the grants round. And these are specific contributions that might require more time. They, we're up to a 4-hour slot. Somebody can contribute. And so these might be somebody putting on a bespoke theater performance, recording it, and then using that as the entropy that goes into the ceremony. Other people we have another group that's blowing some things up and then recording the entropy that results from the explosion. Some really cool projects that are in there, and I think we have about 15 different contributions that are doing these crazy and wacky ideas. And the point is like to produce these events that are pretty complex to pull off, just as a way to, one, provide a cultural marker that this was a significant event. Somebody put in time and effort to stage these events that will produce entropy. And then just a little bit of fun, right? So giving people an opportunity to do something that's unique to them or unique to their city or local community. So that's happening over the next 2 weeks, starting April 1st, or not the next 2 weeks, but yeah, April 1st to April 16th. And then we are looking at how we can reopen it back up to the general public, and then anybody can contribute. And then wrapping up this long answer, the output of the ceremony, once we decide like, okay, this is sufficient, we will call for a final output of the ceremony. We'll have a public sort of, we'll encourage people to check this output so that it's cryptographically sound, that it matches up with what we've been running with for the past few months. And then that will go into, so this string of letters and numbers will then go into a client release when it comes time to have EIP 4844 or Dank Sharding go live, which is what kicked off this question. So it's been a long project, a year, not long relative to some other stuff like proof of stake, but relatively long. It's been a blast working on it, but yeah, it will eventually feed into scaling initiatives like Dank Sharding. So that's the long answer of the roadmap and how we've gotten to here. And Carl can give a much better technical answer about like what we're actually using this for and why it's important in for Dank Sharding.
Yeah. So basically, like the idea behind scaling Ethereum, right? We moved to this roll-up centric thing where it's like we have all these cool L2s, but the L2s, like they're bottleneck now for making things really fast and really cheap is the cost of putting data on chain. Which is like, if you scale to like thousands and thousands of transactions, then like all of a sudden it costs a lot just to take this data that the L2s, like they do all the processing on the L2 side, but we still need something to do, like we still need some place to store that data, and that's on chain. And so the idea behind Dank Sharding and EIP 4844 is to provide a really cheap data storage. You can't compute anything. It's just like, yeah, we have this like massively cheap and really available data so that the L2s can offer cheap transactions to their users. And we use some like really fancy cryptography and polynomial commitments. This is where this KZG keeps coming up. It's the name of some authors of a paper that came up with this really cool polynomial commitment scheme. But it relies on the secret construction that no one knows, which is this Lego box that we were referring to earlier. So this construction that no one really knows what it looks like, that sits at the heart of this KZG ceremony.
Amazing. Yeah. All in the name of scaling. And I love it. Friday the 13th and April Fools. So exciting. And then can you tell us how can people get involved in these next stages of the ceremony?
We've had up till now a little over 83,000 contributions. So like there's already been a large like swath of the community. And then for the special contribution period, we've like had a thing where people could like sign up and join, particularly if they have like these cool projects, and we opened this up to grants to fund people to do this. So that's been these contributions. And then as Trent has mentioned, we're looking into opening it up again afterwards. So after April the 16th, it should be available again for people to look into contributing. So after that, look on Twitter and like all the usual crypto news places for like the new ways of contributing. But they're basically the same as what we've already had so far, but just running again, because the idea is we want to have as many people and like as possible. We want everyone to have had a fair chance. We've already had 3 months of this, of open contributions. But like offering more people is always interesting. And it looks like EIP 4844 is not ready to ship from the like client side of things. So right up until that moment, we'd like to try and make this as open as possible to get like a few more contributions from those who haven't had a chance to join yet. We've reached a point now where we have so many contributions where like it's very different from past ceremonies. There's been like 6 people in a room who get together and have to perform a real ceremony thing. But now when you have like so many, like at what point does it stop mattering to add people? It's like a question you got to ask yourself. Obviously more is always better, but like adding one more person at this point is like adds very little relative to adding one person when you have 6 in a room. So those like trust assumptions are getting very different over time, which is interesting to see, and like different from past ceremonies.
Yeah, I can add to that a little. It's obviously important to have this be openly accessible and that it was a public ceremony. But one thing that I think is important to mention is, the marginal benefit of adding more people isn't necessarily going to increase the security at this point. So when we first started this in January, our goal, we were shooting for 10,000 people. We're like, wow, that would be incredible. 10,000 would be the largest setup of this kind. And the most recent one was Manta Network, and they had gotten 4,700 contributions. So we wanted to get double that, and that would have been a huge success in our eyes. Now we're up to 86,000 or 83, something around there. And what does that actually mean? So one thing is, we don't want people to feel the obligation that if they don't participate, they can't trust the mechanism, right? It may feel nice to participate in the ceremony and sort of leave your thumbprint in the wet concrete of Ethereum, but you don't really need to. If you're worried about trusting this output of the ceremony, it's not really necessary because there's such a large number of contributions. The trust model is that all of them would have to be compromised in some way, or all of these contributions would have to collude or talk to each other, meet up, find each other online, and talk about how they can reveal their entropy, assuming they remembered it. And then they would all have to do it sequentially, figure out the order of things. And that's just really not practical. So of course, we want as many people to contribute as possible. But if you can't, for whatever reason, you can also trust that this is secure because of the number of contributions, the number of different clients that have participated. Just because you as an individual don't participate, it doesn't reduce the security guarantees. I think that's worth mentioning.
Yeah, I guess with that, Chris Hobcroft sparked a philosophical conversation on Twitter. And it led me to question, if you yourself do not participate and throw away the entropy, then knowing that you've done that, how can you trust the system? Like, how do you know that actually happened?
I was just going to say, at the end of the day, you're trusting somebody to implement the cryptography. So even myself, as somebody who's worked on this for a year, I didn't work on the cryptography side. So I'm trusting Carl and I've probably 5 or 6 other contributors who worked on the sequencer code, the actual cryptography. There were people that audited it. At the end of the day, you're trusting somebody who has greater technical skills than you to implement this stuff. And you trust that they've actually done the work that they're saying that they've done. So there's trust at some point of this process, but I guess, specifically with regard to Chris's question about the entropy. So you could, yes, if you did remember the specific bit of text you put in, that you could remember that. But there are also 2 other forms of entropy that we ask people for. So you're also moving your mouse around, and the browser takes a snapshot of where your cursor is at specific points in time. And then your browser also generates randomness locally. And all 3 of these are combined to create the random output, or the entropy that is computed over. So you would have to remember and record all 3 of these. Not just for yourself, but for every participant in the ceremony. So 86, over 80K people for accounts is once you start to think about how impractical that is, at least for me, it's totally unrealistic that this would get compromised in this specific way of people remembering their entropy. There's totally a possibility for other ways that it could get compromised, and so that's possible. But in this way of the entropy being remembered, or you have it somewhere embedded in your brain and you actually haven't forgotten it, I think is not really feasible.
I think is sort of to Trent's point is not possible. Our attacks and failures now look like there is a bug in every operating system, or something fundamental about the way we think about cryptography is broken. We're going to a different level of failure where it's people colluding, because I think that's we've reached that point where that's just really not likely or possible. And so we really need to come up with weird and fun failure models before I think we actually have this breakdown.
Quantum computers appear tomorrow. Maybe that's one thing we haven't thought of.
Silo Finance protects borrowers from risk with its innovative risk isolation. Unlike traditional lending markets, when you borrow on Silo Finance, you know your risk upfront. Join thousands of users borrowing and lending crypto you cannot find somewhere else. Bonus, they're running an incentive program, so you might earn additional yield while enjoying your peace of mind.
I want to double click into the roadmap in a moment, but since we're talking about the number of participants, maybe we can also talk about the computational effort. So Nicholas Ramsed on Twitter asks, how does the KZG ceremony result and participation compare to other ceremonies conducted by other projects? How big was this result?
So the actual computation you're doing, if you participate in the ceremony, is like laughably tiny. I mean, your computer will still like heat up and your fans will go flat out for 10 seconds or something like that. But like in comparison to previous ceremonies, the like actual data you're working over is like 3.5 megabytes of like actual compressed data. Whereas for some of the previous ceremonies, we've had hundreds of gigabytes of data. So just like orders of magnitude, like hard to plot these on the same graph. So in terms of the like actual computation and data here, that's really, really tiny, which is, I mean, just super cool because it's enabled so many more people to contribute, which has been fantastic. So really appreciated that. It's kind of just due to the nature of what we're doing, our particular needs for KZG commitments are that and the way we're implementing them in EIP 4844 are really small. Like we don't need that many points. Like we don't need that much cryptography and that much computation. So we're just really lucky that the needs sort of line up with making it easy. So it's not that we've done some clever tricks here or something like that. It's just what our use case is made it like really easy to do this. But now that we've had like so many people contributing for like so many months, the total amount of compute that's done is like actually starting to add up, because it's like a small amount of compute, but by the time you multiply that by 80,000, it's starting to get to a reasonable amount of total compute that's been done on this.
Yeah, I can jump in and also add, I think one of the things that we're excited to share is that this is the largest ceremony of this kind, but obviously you have to take into account the context of it's very tiny, especially relative to these other ceremonies. Like Carl said, like sometimes hundreds of gigabytes. Transferring that between each participant is pretty difficult. You have to schedule it in advance. And so this isn't whenever we mention that, we want to make sure that we're giving props to all the people that did work before us. Zcash, the very first setup of this kind was 6 people, and they had to do a ton of manual work. And we're really just building on their work from 2016 and the successive setups. And now they don't, the Zcash protocol doesn't even use a trusted setup. I think it's Halo or Halo 2, one of those. We're really just building on the work of so many people that have done this before us. And ours is, we're fortunate to have a lower computation requirement that we can get this significant number of participants.
Amazing. Yeah. Congratulations. It's super exciting to see so many people participating, and hopefully we can hit over 100K by the end. Amazing. Well, let's dive into the roadmap a little bit. So EIP 4844, can you tell listeners what that is and share a little bit about the timeline?
EIP is on the name we give to like major proposed upgrades. The P in there stands for proposal, Ethereum improvement proposal. So EIP 4844 is the technical name we give to proto Dank Sharding, which is just making really cheap data available for rollups to make rollups able to scale in a cost-effective manner. It's currently like in the implementation phase for one of the clients, sort of sorting out the final details there, and where it'll go into the upgrade after the current one. So the next thing we're doing in Ethereum like protocol land is enabling withdrawals. This is like very important for like proof of stake and like completing this cycle. Like so many people have just trusted the protocol and like put their faith in Ethereum developers and the Ethereum roadmap, that like they deposited their 32 ETH, and began staking. And now it's time to like enable them to like be able to extract this, their stake too. So like complete that life cycle and like the original promise that we made when we switched to proof of stake. So that's been really cool. And then the second thing I'll pop, so that's withdrawals. And then after that, we're looking into our future upgrades. So the next upgrade after that, will be EIP 4844. And that should hopefully be somewhere, towards the latter half of this year, where we, will ship this really cheap data for L2s. So that's like the next big upgrade plan. And then things beyond that are more in the research, like pipeline. We haven't reached the implementation phase for those things, like SSID and in protocol PBS and all sorts of fun things like that, where it's like we're not even sure that there are ideas that will eventually make it into the protocol, because there are many unanswered questions, and we're still exploring them as research ideas.
And I'll emphasize, we hope it will go into the next upgrade, but there's no guarantees. This isn't a projection of any roadmap or guarantee of a feature being included at a certain time. Yeah, I know. I mean, when I was on the other side of this, not being like deep into protocol coordination, it's a spectator sport for a lot of people in the community. They love to engage with the protocol upgrades and be aware of the latest thing that's happening. And I totally get it. But it's deep in the implementation phase, and we're ironing out a lot of bugs. So hopefully later this year. But just we're not making any promises.
Totally. We don't commit to timelines here. Amazing. Okay. And then Dank Sharding. Can we talk a little bit about how it got its name? I know it comes from the researcher Dankrad, but is there is it a meme?
Oh, it's definitely a meme. We have this like terrible thing where we love coming up with stupid names for things. And like, I think if there's any marketing department involved in Ethereum, they would be cringing and hate it the whole time. But for us, it's important to like, when we have these things that we're working on for so many years, to like remember to have fun with all of them. And like, this is just one of the ways we really do that. So yeah, it was named after one of my fellow researchers, Dankrad. And yeah, I mean, it was just like his proposal for simplifying things and using these KZG commitments in this particular way. Where it was like Ethereum used to have this like really complicated sharding vision, and then Dankrad came in with this like massively simplified vision, and it was like really cool to unify on that. And we're talking about like Dankrad sharding proposal. And then the meme of like Dank Sharding was born. And then we've like even like further, like we further simplified that into like EIP 4844, which is like a version of Dank Sharding called Proto Dank Sharding. Proto used to be a researcher at the Ethereum Foundation, now with OP Labs. But also for like similar things, like we added his name to this because he also added like dramatic changes in the early days. So yeah, it's just us playing around with a fun idea here.
Amazing. And then staking withdrawals. Can you tell listeners what that is and any timeline you can share?
So, I mean, we're kind of in the, like, we have many testnets and stuff deployed for that. So, in the beginning, right, we had the beacon chain, which launched, and there was the deposit contract, on Ethereum, which is basically just a contract you send your ETH to, and the contract just takes in ETH, and then on the execution layer side of things, nothing more happens, right? It's just a black hole that we keep sending ETH towards, and this contract's balance sheet gets bigger and bigger. But like the ETH can't go anywhere or be withdrawn anywhere. And it's just like, that is where the ETH gets directed. And then, so we have this like second thing, which is the beacon chain, which is like watching this contract. And every time someone makes a deposit, we like create a new validator for them at and with the balance that they deposited. So it's like you send your money here into this black hole and it magically appears in this other place, which is for like where we're doing this, which you then stake, and you do all your validation duties, attesting to like, hey, this is what I think is a valid block. I think this is the head of the chain. Maybe propose a block. These kinds of things that you do as a validator. but there's no way of getting this money out of the beacon chain. So we combine the beacon chain and the execution chain after the merge. But in many ways, the execution chain is like not really like aware that the beacon chain exists. The beacon chain is like just sort of in the background, like zombie mind controlling the execution chain and like making all the decisions on like which blocks it must choose and those kinds of things. But there's like no way to reverse this process. So this was a decision we made in order to make the merge happen sooner, to simplify the merge and de-risk the merge, which like went down really, really well. So I think it was a good decision, particularly considering how long the merge really took anyway. So I think this was like simplifying is something we've like really learned to do a lot over the years. And so withdrawals are the idea now is that to make a way for people to take their stake from when they're done, when they want to stop validating, and to take the rewards that people have been earning over the past few years out of the beacon chain and put it back into the execution layer. So it's like a way of taking your stake ETH and you like recreate it, like disappears on the beacon chain and reappears at the execution layer. And that's what this withdrawal process is. And it now means that we're like even more tightly coupled things. That's where like a little bit of this complexity comes from. So we're in the like final timelines of like actually shipping this. We have like test nets that are running for like people to deploy and run this. And like now we're like ready to actually ship this thing in very short order.
Yeah, and we've chosen a mainnet date of April 12th.
Oh, exciting. Amazing. Great. Very exciting. And when you make changes like that to the roadmap, how do you generally approach that with the community and letting them know? And how did they handle it?
The Ethereum governance is always a very complicated thing, and it's changed dramatically. So when we first started with this whole proof of stake thing, it was basically a few of us researchers were the kind of benevolent dictators of what would happen next on Ethereum. And the idea more being that like we'd propose some changes, and if the community liked it, they would like accept it and like put money in the deposit contract, and like the client teams would build out these proof of stake systems. And if the community didn't like it, we wouldn't go in that direction. But people seemed to like it, so it seemed like a good thing. But this model like helped us really build things very quickly. It's a relative term, but allowed us to rapidly like iterate on ideas. But now we're moving away from like these kinds of things. So we're trying to like more ossify Ethereum as a protocol. So like these changes are far more slow to happen, and there are like fewer people making these decisions. We like require the whole community and more discussion, and really like having this. It's always been in the open, but like really make sure that these discussions we request like input from as many people as possible. So there's like the roadmap is like when you see roadmaps on Twitter, that's usually there are like two levels of it. One is when you see Vitalik posting some tweet with like, here's the roadmap. That's like his particular view. It doesn't mean much beyond that. And even like some of us researchers disagree with him on what that should be and what the order is and how important things are and how far along things are. And that changes things quite dramatically. And then like as things get closer, it just like, and people like the client teams implement things as they get ready and closer to ship. There's like far more discussion, and we have these calls for like, should we include this change or that change? And like, we try to bring all the like stakeholders to the table in terms of like having pretty good discussions here. And then we like schedule an upgrade date like we have now, April the 12th for withdrawals. And if the community all updates their software, then things get shipped. So it's like many like different pipelines, and it's like until things are actually included in the client code, most of it's just like various people's opinions on what it would look like, as opposed to like the roadmap, which I don't think really exists anymore. It's just like a bunch of ideas that people think would be cool to include over time.
Yeah, I can expand on that a little bit. But one thing, so the process has always been by default public, by default open. Anybody can propose an EIP. Iterative, very focused on tweaking an idea, communicating it to the other developers, changing it based on feedback. And over the years, it's gotten even more doubled down into these characteristics. Because the community has grown, there are, from the start of Ethereum, it had these characteristics, but to today, it's become even more important to engage the broader community in framing the protocol, what it's going to look like in the near future, what it's possibly going to look like in the far future. And if the broader community isn't engaged in these, you don't actually know what the needs are of the people that are ultimately the end users, of people that are purchasing or extending block space. So I think that's one thing that's really important to emphasize. And just as more larger companies and different organizations with different interests have started to become engaged in the process, it's become, again, important to maintain this open access, by default, public, iterative process, because otherwise you end up with, people making decisions in back rooms or, less than good outcomes for where the protocol should go.
If you liked our recent episode with Matthew Gold on digital identity in Web3, then I have the perfect podcast for you. Web3 with A16Z Crypto. Produced by venture capital firm Andreessen Horowitz, this podcast is your definitive resource for the future of the internet. From the latest trends to research and insights from top scientists, developers, and creators. And if you need somewhere to start, I'd highly recommend listening to their heavy-hitting episode with It's Always Sunny in Philadelphia's Rob McElhenney on the future of decentralized media. Follow Web3 with A16Z Crypto on your favorite listening app. Tell them that Defiant sent you.
And then 2 more pieces on the roadmap. And then I want to ask the purpose of all of this. The proposer builder separation. Can you tell us what that is and any timeline you can share?
Sure. This goes all the way back to the early days of MEV Geth, which is back in the proof of work days. There was this fork of Geth in order to basically have someone else send you send you the blocks as they think they should be. So someone else would do all the searching. This is when lots of the innovation from the Flashbot side of things has come about. Someone else does the searching, finds some blocks that extract a bunch of MEV. And so there we're starting to separate the role of who's mining the block and who's actually putting transactions in the block, because those are kind of different roles. The one back in the mining days, you needed farms worth of ASICs or GPUs, and the other side, you need people with really advanced algorithms and all sorts of fun things to try figure out how to extract MEV from a block. So we've had some kind of separation for a while, and then early in the from the pretty much the near proof of stake, we knew this was going to be a thing. So there's this idea of MEV Boost, which is a piece of software which does a similar thing. And this is maintained by Flashbots. But again, it's if you're a proposer, you're not going to build this block yourself. You're going to have someone else run all these complicated things because you're, as a proposer, you're no expert. I run some validators. I have no idea how to extract the most MEV. It's a full-time job. And so they're teams of people probably way smarter than me working on making sure this all happens. And so we already have this separation of concerns between the people who are specializing in actually building blocks and the people who are putting the blocks on chain as a proposer, the next validator. So we already have proposer builder separation, but there's this interesting research idea of making this in protocol. So basically taking the software, which is MEV Boost, which is this separate thing as these are the people that do the proposing, and validators choose whether or not they run the software or not. And taking this piece of software and making it a part of the protocol. So there's the beacon chain becomes aware of hey, these are the searchers who are trying to find all this MEV. And these are the proposers who are trying to build things, and we can force proposers to choose certain blocks and keep the searchers honest about the way they build blocks. And we can do this right now it's done with some reputation, and there's lots of discussion over who you which sequences you're using. So relays is the word we use here. Which relays are you choosing to use for running MEV Boost? We could take all these people and just put them all basically on chain. And this allows us to do cool things. So now the chain is aware of like how much MEV is in a block. So like if some relay is like, hey, to the next validator, hey, validator, if you include this block, I will pay you 1 ETH. We now know that there's like at least 1 ETH of MEV in this block. So we can like do things where it's like, okay, we can like maybe give the validator some of that, but we can like direct this funds elsewhere and most likely would burn it. So it's like this like cool way we can like try like recapture this MEV instead of having it like all basically be directed towards validators. If we have in protocol proposer builder separation, we can take the value that these builders find and do something else with it that's not giving it mostly to the proposers.
Okay, great. And the last piece on the roadmap is just the single slot finality. Can you share what that is and any timeline you have?
Sure. So single slot finality, that like the way the beacon chain works is we work in epochs, which is roughly 6.5 minutes. And in that time, everyone who's validating gets a chance to vote on like, hey, I think this will forever be a part of the chain. Like this block way over here is going to be a part. And then we have a second epoch after that, which is like after that we check that everyone saw that everyone agreed. So we're like, do this thing where it's like, hey, I saw that everyone else sort of agreed previously that this was a thing. So we like move in these 6.5 minute increments, which means in order to have the like full economic value of the Ethereum beacon chain and all these validators, like all the stake they build up behind your transaction, you need to wait 12, 13 minutes for everyone to commit to this. So there's this idea called single snuff, which is basically how long, and this is called finality. Once we're like, everyone agrees with all the economic value of the validators behind us, like this block will never be removed. It's final. The idea behind single snuff finality is trying to have this all happen within one, like a slot's the time we allocate for a block. So basically within one block, have everyone agree. So, this like really long timeline that we have where it's like, wait, this 12 minutes is a trade-off we made initially to, have enough validators, like be able to have like crazy, numbers of validators participating. And this is like why Ethereum as a proof of stake model has so many more validators than other proof of stake models, is because it's really easy to do this. But this like has the downside of taking really long. So single slot finality is like using some really fun optimizations to try to compact this data to the space of a block. And maybe we need to like take a block from taking now 12 seconds to 24 seconds. But if we can come up with a really cool way of like including everyone's votes within that, then we can like really compress this timeline and have like the economic weight of your like guarantees about your transactions happen in like half a minute as opposed to 12 minutes. In terms of timeline, this is still something very much in the research phase. Like as a protocol, one of the like fundamental beliefs of Ethereum is that anyone should be able to run this on like you shouldn't require a fancy server or really expensive computer to be able to do this. You should be able to do this on any quote like reasonably modern computer. I mean, you can currently validate Ethereum on a Raspberry Pi, which costs $30-40 dollars. So that's like making sure it's cheap and accessible is really important. So it's like, how can we maintain that, but still have like so many people voting? And so there's like a bunch of research ideas around making this happen. But in terms of like actually shipping it, it's multiple years away. Because we need to solve many research problems and then like lots of complicated client problems and require quite a big re-architecture of the system, sort of similar to the merge kind of levels of change.
Absolutely. And I appreciate that because I think many define decentralization as an ability to be able to validate the chain yourself at a low cost. And I think it's an important component to this. Okay, so zooming out, let's say scaling is complete. What are we going to do with all this additional block space? What are some of the use cases you guys are excited about?
Fortunately, we don't have to figure any of this out. There's other people doing the hard work of getting new users, figuring out what to do with all the block space. For example, I feel like there's every week where there's a new roll-up kit or roll-up as a service product that launches, which is incredible to see. It's incredible to see it becoming easier for developers or companies or applications wanting to launch their own chain, that they'll have these products available to them. But yeah, I'm very happy that we don't have to do the hard work of building out product and iterating with users. That's its own fun journey for other people. But yeah, I generally, I think that there will be new use cases unlocked by abundant, cheap block space. It's just a matter of finding out what those use cases are and connecting the right users to actually use them, which is probably more broad than you were hoping for. But I think it's so wide open that it's hard to know exactly what kind of products there will be. Probably on-chain gaming, or some hybrid, not where you're putting every game move on chain. Like there's some interesting stuff with on the OP stack. Forgetting the name of the project, Lattice. I think Lattice is the name of it, but they're doing some interesting stuff with gaming. But yeah, it's kind of like what sort of things were you able to do on the internet in the broadband or in the dial-up era versus broadband or satellite? You know, you can do many more things. You can pipe around tons more data. And now we have the internet as we engage with it today. And you'll probably see something similar where applications or products that weren't enabled on a 14 transactions a second mainnet Ethereum, these are now possible on these new layers that have abundant cheap block space.
Yeah, many think gaming is kind of what's going to lead to mass adoption, but I'm more excited about changing incentives and coordination so we can actually solve some of the biggest challenges in the world. And I'm hoping that we kind of gear things towards that direction eventually. Carl, anything from your side that you want to share that you're excited about on the use case side?
I mean, again, like it's hard to imagine. It really is like a new paradigm. Like it's such abundance. It's like hard to think past the current constraints. So like in the early days of Ethereum, when it was like I still used to run a node on my laptop, like at the end of the day when I was like done doing my other things, I uploaded like some images on chain just for the hell of it. I was like, hey, I want to store this forever. And it was cheap enough to do that. And I'm not saying that that's an intelligent or sensible thing to do, but it's like the idea of doing that now would like literally cost you like thousands and thousands to do. It could just be such a stupid idea. So it's like what do you want to do? How can you change things? So it's like very hard to see into the future in terms of what new options are available to people. I agree that like many fun, like interesting NFT and gaming things, which are like people are talking about and excited about. But it's like, those are just sort of extrapolating from where we are right now and the possibilities we can see right now. But when we can like completely change the paradigm in terms of like the costs to do things trustlessly, then like all sorts of, as you're saying, like fun coordination things become possible at like global scales. And so like if we want to do crazy things that involve like many orders of magnitude more people, in ways where it's like we don't just trust like the big tech companies or a government to do something like that. That's like cool infrastructure we've never had. So like what that leads to, I don't know, but I'm excited to see what it is.
Yeah. And one other thing I can add is like, a lot of this stuff isn't necessary. Like L2s have existed for a little bit, or at least the idea, and they're coming into their own as a place for people to launch products. And so I think part of it is the builders actually have to become accustomed to what the new capabilities of this ecosystem offers, and combining all of these different affordances. And as we've gone through the years, I think UX has gotten slowly better, still pretty bad, but getting better over time. And L2s having faster confirmation or cheaper fees is one component, I think, that helps us along this path, but it's not going to be the end. Yeah, it's not going to be the final arbiter of whether a product is successful or not. So it's still going to require people to have good ideas and good execution. If you're looking for specific products, one thing that's really cool I've seen recently is called SteelCam. Kind of, I don't think that they pitch it this way, but it's like an on-chain OnlyFans, where you can steal photos from people for a price, and then the people who have previously stole it get some cut of that. So it's an interesting some game mechanics. I don't think they would not describe it as an on-chain OnlyFans, but I think it's very well suited for that, because you can have a fan base of people who are interested in purchasing your individual photos. And that's a really cool thing that I don't know if they've been able to abstract some of it away. There's probably a little dash of centralization somewhere in there, but it's a cool product. People should check it out, as I think one of the recent things that I've seen that is enabled by, I think it's on Arbitrum. Yeah. Check it out. SteelCam. Try SteelCam.
Totally. I'll check it out. Amazing. And then why are you both passionate about this? Let's say, what do you think the impact will be in like 10 years from now? And why have you dedicated so much of your lives to solving this problem for Ethereum?
I mean, I think fundamentally Ethereum is a coordination layer. And I think we're seeing the like limits of the existing systems we have for coordinating. I think we're pushing up against the limits of governments and these kinds of these existing institutions, where it's like they're sort of like falling prey to some of their like earlier failures, and it's like less easy to overlook things like that. I think large tech companies, it's like very, very hard to have a voice as an individual against those kinds of things, and to choose and operate differently. And these systems are very opaque. So like, I'm really excited about these like ideas around being able to coordinate around things as a society in a completely like trustless and open way for everyone. Like choosing, like your jurisdiction doesn't matter, like who you are, like what your history is, like none of that matters. It's just like everyone has this like platform that doesn't like completely agnostic to who you are, what you're trying to do. It's just this layer for you to coordinate, collaborate with other people, and like build something on top of that. And I think that's like a really cool, exciting primitive that could lead to really interesting options for many people in different walks of life. I think that's an exciting future.
Yeah. For me, definitely seconding all of that, but I can echo or focus on how Ethereum and for all the blockchains they're adding augmentations to, or rapidly expanding the total available trust that we can disseminate into the world. And that's important, because trust, or not needing trust, I guess we can go back and forth between those two ends of the spectrum, is you often require an intermediary, right? You trust your bank to hold your money for you. You trust financial counterparties to execute a transaction for you. And as we've designed our worlds to be intermediated, that allows for centralization, or these things kind of develop alongside each other. Centralization, censorship, removing someone's access, not just to funds, but different aspects of their lives. So the more that we can do to onboard the world's financial system, the world's trust layer to these types of systems, we can hopefully reduce the amount of censorship, the centralization, or the negative externalities that come from a system that's built on something that requires trust in these different products or just different relationships. That's why I think it's important to work on Ethereum specifically. And what I'll probably be doing for the next 5 to 10 years.
Amazing. I love it. We're shaking out all the centralized points of failure. And one thing that I've noticed is just, and I'm guilty of this too, kind of coming into the ecosystem early days, rainbows and butterflies, and everyone's going to do the right thing. And now we're seeing that maybe not. Maybe the tech companies and the governments aren't going to do the right thing. And maybe they want to kind of keep their hold on the power they have. And I've noticed the Ethereum ecosystem specifically has kind of become a little bit more adversarial. And so would you agree with that? And how are you kind of thinking about that within the Ethereum ecosystem?
I mean, I think the big difference that's happened over the years within the ecosystem is that there's become incredible amounts of value here. back in the early days, it was a lot more playful and rainbow and butterflies or whatever, because there's a lot more trust. And we're always aware of like issues and around security and safety, but it was like easier to overlook those, and those are less important. But now as there's like more and more value everywhere, we're like adversarial thinking. Like instead of it's like, oh, hey, we imagine this attack could happen. It's like, if you can imagine an attack, someone's probably going to execute it. So it's gone from these like theoretical ideas of like, this is how it could go wrong, to like actually seeing people trying any and all possible ways to make these things happen. So I think like internally, we've gone from just thinking about these theoretical things to like knowing that you have to, and maybe like, oh, hey, if this does happen, we could implement this solution. It's like now, like you need to have those solutions in place right from the get-go. So like that's really required. And then I think the second thing is just becoming more and more like, as Ethereum has grown and more people become aware of it, and particularly like governments have become aware of it, it's becoming more and more important to make sure that we don't get captured by some weird, like basically like Ethereum doesn't get boxed into a corner by some weird regulatory structure. So I think the mindset of most researchers and developers in the space is to try ossify Ethereum. So like, let's figure out how to make these big changes that need to happen to like offer fantastic scaling to everyone, like dramatic security improvements and user experience improvements, but then to like try and move more directionally towards the Bitcoin thing of like we're like not making any more changes, and basically to try beat the regulators who are trying to like lock down on these things by like becoming really fully featured before then, such that it doesn't really matter that they could like lock us down, even if it were to happen. Like worst case scenarios, like Ethereum may not change from like the current model in a few years' time. That's like we like reached a point where that doesn't really matter, because Ethereum is so capable anyway that we can reach most of the original goals and visions with what we have.
Yeah, I think that that's a really important point that not a lot of people talk about. It's like we came in as idealistic kids, and then suddenly billions of dollars appeared, and we had to grow up pretty quickly and become a little bit more pragmatic. Amazing. Well, I know we're at time. Maybe we could schedule a part 2, because I feel like there's so much more to dive in here. But last question, and then I'll let you both go, is just how are you Defiant?
So I think I think everyone in the ecosystem is Defiant in their own way. Like, I don't think you're a part of this unless you're like, have these visions of how you could change things, or like dreams for different trusts and coordination systems. But I think me in particular, as I go a little bit further than most, and like trying to really believe in like a bit more of the original cypherpunk vision for some things. Like I really want this I think there are many sacrifices we should make to ensure that Ethereum is this like value neutral, trustless system. And like what happens on top of it, I'm less concerned about. But if we have this platform where it's like really hard to capture, that is really, really robust, I think that I would go further than most in making trade-offs in that direction to make sure Ethereum remains this way and can remain this way in the future. And I think that allows us to have like a really strong base layer to build fun things on top of. So for me, that like directs my research quite a bit in terms of like how we execute things, and to make sure that they are as robust as possible.
I will echo that actually as my answer as well, so maybe in a different frame. So when I'm thinking about designing things or working on specific projects, I guess also going back to your question of, is the Ethereum community more adversarially minded? I think that's sort of at the core of what these systems are predicated on and how they're built. Like, there's no way to get around how the chain operates and how you structure incentives to get people to do certain things. It's baked into how the core foundation of all of this works. So it's unavoidable in some respects. But for me personally, I think it's worth leaning into, because if we're not pursuing this both at the high level, the protocol design, but also on your personal projects, if you're not pursuing excellence in trustless mechanism design, or trying to game out ways in which something can get compromised, and trying to think about the ways that it can fail. If you're not doing this on your own, somebody's going to do it for you. So I guess I'll invent some sort of like excellence in design ideology or this belief that you should be pushing towards the most trustless, the most secure, censorship resistant design that you can. Otherwise, you're not doing a service to both the people that built this stuff years before you and the people that you hope to use it in the future. So I guess to summarize all that, the way I would be defined is just by making sure that I'm staying true to the ideals of what we're building and why we think it's important long-term and not losing sight of that, even though the surrounding community may get more adversarial or the pressures to compromise in certain ways might get more and more intense.
Amazing. I got chills. I appreciate both of you and all the contributions you've made and are making. Amazing. Thank you so much for coming on the Defiant. Really appreciate it.
Thank you for hosting us. We really appreciate it.
Thanks for having us here.